So now we're going to look at these Lewis structures and other formulas, such as if we look at the Lewis structure, we can also call that a dashed formula. We're also going to look at bond line formulas. Condensed formulas. And then lastly, just a brief look at molecular formula. So again, keep in mind with the periodic table, hydrogen has 1 valence electron. Carbon has 4 valence electrons. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. And fluorine has 7 valence electrons. And this does include all the other halogens, such as chlorine, bromine, and iodine. So again, these are the valence electrons. These are the outermost electrons that are involved in chemical bonding. So looking at these atoms, we can create a general table. We can look at the number of bonds that these atoms will form, and we can also look at the number of lone pair. And remember, this is for a neutral atom. So if we take a look at hydrogen, hydrogen can only form 1 bond, and hydrogen will not have any lone pair. If we take a look at carbon, carbon we said was tetravalent, so it will form 4 bonds and for a neutral atom. So again, we're talking about a neutral carbon. It will have 0 lone pair. We can talk about nitrogen. Nitrogen likes to have 3 bonds and 1 lone pair. Again, we're talking about a neutral nitrogen. Oxygen likes to have 2 bonds and 2 lone pair. Again, we're talking about a neutral oxygen. And lastly, if we take a look at our halogens, for example, fluorine. Fluorine likes to have, or any of the halogens like to have 1 bond and 3 lone pair. And again, we are talking about the neutral atom, in which the charge is 0. Keep in mind that you have to show lone pairs in Lewis structures and bond line formulas. You have to show lone pairs, you have to show those dots in Lewis structures and bond line formulas. In the previous video, I said to find the number of hydrogens to be attached with a carbon, you would have to do the following formula. Take the tetravalency of carbon and subtract the number of bonds. And that is how you can find how many hydrogens should be attached. We said that a CH3 group is going to be on the end. We said that a CH2 group is going to be in the middle. And being that it's in the middle, we also said that it splits in 2 directions. So it splits in 2 directions. And then lastly, if we had a CH, it also splits, but instead in 2 directions, it splits in 3 directions. So let us now start looking at a few examples. Here I have first example, C2H6. This is a molecular formula where it tells you the total number of atoms, the number of carbons, and the number of hydrogens. We should be able to draw the Lewis structure for this. We said that carbon is tetravalent, and we have 2 of them. So we put our carbons together. And we have 6 hydrogens. So if we split that between the 2 carbons, 6 divided by 2 is 3. So that means that each carbon will be attached to one of the hydrogens. Each carbon is going to be attached to one of the hydrogens. So here we have our Lewis structure, which essentially is the same as our dashed formula. With the dash formula, you see how all the atoms are bound. We should also be able to write what is called a condensed formula, where we're going to see the letters and numbers as subscripts. So we look at the Lewis structure in order to do the condensed. On the first carbon, we have CH3. And on the second carbon, we have CH3. Or if I wanted to write it as H3CCH3, I can. That represents the condensed formula. Now you'll see from the Lewis structure that this particular compound has all single bonds. So this compound is an example of an alkane. And remember we said alkanes have the general formula CnH2n plus 2. The last thing we want to do is look at writing a bond line formula. With the bond line, you do not write carbons or hydrogen atoms. Unless it is attached to a what we call heteroatom. Heteroatom would be like an oxygen or a nitrogen or a sulfur. Something like that would represent a heteroatom. Also with the bond line, we write it as a zigzag. So up, down, up, down, up, down, up, down, up, down. This is a zigzag pattern. Again, that up, down, up, down, up, down. Where this represents 109.5 degrees for the bond angle, and it also represents the hybridization being sp3. So the ends represent carbons and the middles also represent carbon atoms. And you do not have to write your hydrogen atoms. So for our C2H6 compound, its bond line formula would just look like a line because it's only 2 carbons. So let's look at another example. CH2, CH2. Now the way that I've just written this represents a condensed formula. Again, that's when we see no bonds. We see the atoms and their subscripts. So I can count the number of carbons I have, C2, and the number of hydrogens, H4. And I'm able to write what is called the molecular formula. I can also write my Lewis structure. Carbon is tetravalent, and we said to split the hydrogens in between the carbons. And in order to obey the octet, we would have to put a double bond. Here, this represents the Lewis structure, or we can call it the dashed formula. And if we wanted to write the bond line, if we take away the hydrogens from the dash structure, so I'll write the dash structure. if we take away the hydrogens, we're left with carbon, double bond, carbon. But remember, in the bond line, we do not write carbons. So now we have to remove the carbons. So for the bond line, you would just have a double bond, or essentially an equal sign. Let's try another example. Here you only see 3 lines. So therefore, this represents a bond line formula. What if I decided I wanted to write the Lewis structure? I'm given a bond line formula, which has 3 lines. A carbon should be here, a carbon should be there. And I know that carbon is tetravalent. Right now it only has 3 bonds. So I would have to go in and put in my hydrogens. And I've just converted a bond line structure into a Lewis structure. What if I decided I wanted to know what the molecular formula was? I count my carbons. 2 carbons. Count my hydrogens. 2 hydrogens. C2H2 would be my molecular formula. In order for me to write my condensed formula, I would need to take a look at my Lewis structure. It says H, C, C, H. If I read it like a book from left to right. Or sometimes you may see it written as CH, CH. Now, because you see a carbon-carbon triple bond, this is an example of an alkyne, which has a general formula of CnH2n-2. And if we go up to the second example that we had, the first example, we said that its formula was CnH2n plus 2, which was an alkane. If we look to the right at our second example, this is an alkene because it has a carbon-carbon double bond, and it has the general formula CnH2n. And then the alkyne, which we just looked at. So let's add on and let's look at another example. CH3, CH2, CH3. Now, if we look at this formula, this is represented as the condensed formula. Again, because letters and numbers. I can write this formula as a molecular formula by counting my carbons, 3 carbons, and counting my total number of hydrogens. That's 3 and 3, which is 6 plus 2, and that gives us 8. So this represents my molecular formula. What if I decided I wanted to write the bond line formula? I look at the number of carbons I have. 1, 2, 3. And I want to write a zigzag. So that's just a V, because that will represent 1, 2, 3. And this would be my bond line formula. If I wanted to write the Lewis structure, I can take my bond line, which was that V, upside down V. But remember, Lewis structure shows all bonds. So I write my carbons in. Here is a carbon, here is a carbon, here is a carbon. And I'm going to go ahead and label them A, B, and C. To find out the number of hydrogens, I would take 4 minus the number of bonds, and A only has 1 bond. So carbon A is going to have 3 hydrogens attached. 1, 2, 3. If I look at carbon B, carbon B is in the middle with 2 attachments, so 4 minus 2 bonds. So carbon B has 2 hydrogens. 1, 2. Carbon C. If I want to look at the number of hydrogens, again, 4 minus the number of bonds, which is 1, and that's 3. So carbon C is going to have 3 hydrogens. So I've just converted my bond line into a Lewis structure. So we should be able to interconvert into any of these different formats of how we can write molecules and ions. Let's look at another example. I am going to give you this formula. And we should be able to look at the formula and say, because the only thing we see are lines, is that this is a bond line formula. What if I want you to, from here, write the condensed formula? Well, first off, I would start by writing my Lewis structure. I would take my bond line structure and rewrite it. Then I would go in and I would fill in my carbon atoms. Here's a carbon, here's a carbon, here's a carbon, here's a carbon. If it's not supposed to be a carbon, the atom would be written. And just like we did for the example above, we would look to see how many hydrogens we would need to put in. So for the carbons on the end, remember we said those are CH3s. So they get 3 hydrogens. And then the one that is in the middle is going to get 2 hydrogens if it has 2 attachments. So let's go ahead and put those in different colors. So let's go ahead and do our CH3s first. So all of our CH3s, we've put in the hydrogens. And then we have this one in the middle that has 3 attachments, so it only gets 1 to make 4. And then this carbon has 2, so it needs 2 more in order to get to 4. So we've used our bond line to draw a Lewis structure. Now that we see the carbons and the hydrogens, it may make it easier for you to draw a condensed formula. Again, reading it like a book. I have here CH3, here CH, here CH3, and then I can write the rest of it. CH2, CH3. I am not going to, for this one, write the molecular formula because the main thing that we want to focus on are the bond line formulas, the Lewis structure, and or if you want to call it the dashed formula. So condensed, Lewis, and bond line. Let's look at another example. CH3, CH2, 4C, CH3, 3. So the way that this is written, again, you see letters and numbers, so letters and subscripts, which represents the condensed formula. You'll notice we have parentheses. It works the same way just like math with the parentheses. So let's go ahead and let's write the Lewis structure for this particular compound. Read it like a book, left to right. What does it say I have first? A carbon that has 3 hydrogens, because remember carbon is tetravalent, so it likes to have 4 bonds and those hydrogens like to be on the end. Following that, I have a CH2 group, but I have 4 of them. So this is 1, this is 2, this is 3, and this is 4. And that carbon is going to be bound to this carbon, which if we look to the right of it, it tells us that we have 3 CH3 groups attached. 1, 2, 3. So this is our Lewis structure for the above condensed formula. Now that we see the Lewis structure, we should be able to write our bond line formula. Well, let's put it on this side. So we have 1, 2, 3, 4, 5, 6, 7. If I'm going left to right, straight across. So I want to do a zigzag with 7. 1, 2, 3, 4, 5, 6. I need one more line to make 7. And then on carbon 6, I have CH3 groups. So I can do this. So I have just written my bond line structure. Let's look at another example. What if we had CH3, CH2, O, CH3? This would represent the condensed formula. And let's go ahead and make that into a Lewis structure. We have a carbon with 3 hydrogens attached to a carbon that has 2 hydrogens attached to an oxygen, which is attached to a carbon that has 3 hydrogens. And remember, we said for Lewis structures, we have to write in lone pairs if they exist. Not for condensed, but for Lewis and bond line. Now we want to take this Lewis structure and we want to write the bond line formula. So I have 1, 2, 3, 4. So I'm going to do a zigzag with 4. And I'm going to label it 1, 2, 3, 4. But instead of having a carbon at position 3, I'm going to put in my oxygen atom. And I'm going to put in my lone pair of electrons. So now I have just written the bond line structure. And you'll notice again this has that formula ROR, which we said represented an ether. So let's try another example. Let's do a cyclic system. So here we have a 6-membered ring and we just have lines. So this represents the bond line formula. So if I wanted to draw the Lewis structure, which is the same as the dashed, I would keep my 6-membered ring. Here I would have a carbon. Here, 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 and here. All of those carbons have 2 bonds. So that means that they're going to each have 2 hydrogen atoms. So this would represent the Lewis structure, which is the same as the dashed formula. And then lastly, if we wanted to write the condensed formula, we would write in our carbons, and if you want to call it like a modified Lewis structure, that's essentially what it looks like. But we don't show the bonds. From the carbons to the hydrogens. We don't show those bonds. We do show them from carbon to carbon, but not from the carbon to the hydrogens like you see in the Lewis structures.